In this video, we will discuss the convergence of the improper integral 1 over x to the p over the interval 1 to infinity. We will show that the improper integral is convergent if p is greater than 1 and is divergent otherwise. We would like to remark that the convergence of this integral is an important result which will be used in the convergence of P series later on. Since two different formulas apply to the integration of 1 over x dx, which is the case p equal to 1, and to 1 over x to the p dx, where p is different from 1. Like here we apply exponent rule, and over here we apply the ln rule. So we will take up these cases separately. Now integral 1 to infinity 1 over x dx is the same as limit a approaching infinity 1 to a 1 over x dx, which is limit a approaching infinity ln a minus ln 1. This limit over here doesn't exist, therefore, and this part is equal to 0, therefore we find that this limit does not exist. So the case p equal to 1 is settled. Now we take up the case when p is different from 1 if p is not equal to 1, then integral 1 over x to the p dx is equal to this is equal to 1 over 1 minus p times x to the 1 minus p. Therefore, limit of 1 to a 1 over x to the p dx as a approaches infinity is equal to limit a approaching infinity of a to the 1 minus p over 1 minus p minus 1 over 1 minus p. Now, if 1 minus p is greater than 0, limit a approaching infinity, a to the 1 minus p over 1 minus p does not does not exist. Therefore, divergent if 1 minus p is greater than 0, that is, if p is less than 1. If 1 minus p is less than 0, then limit a approaching infinity of a to the 1 minus p over 1 minus p is equal to 0. Hence, integral of 1 to infinity dx over x to the p, and we are considering the case p greater than 1, so that 1 minus p is less than 0, is equal to limit of a to the 1 minus p over 1 minus p minus 1 over 1 minus p as a approaches infinity is actually, this part is 0, and therefore we get that this is equal to 1 negative 1 over 1 minus p, and hence the limit exists. This improper integral is convergent if p is greater than 1, having shown that the integral is divergent in case p is equal to 1 or p is less than 1, so we can say divergent otherwise. So that completes the discussion of convergence, divergence of this integral in general.